Hello, everyone. This is our mechanical engineering senior design presentation for spring 2024. We are the Battlebots senior project, team F41. Our team members are Johnathan, Nate, Jyotaaver, and Andrew. Our sponsor was Kirk Branner, and our faculty coach is Altari Elkand.
So a little bit about the team. We were composed of 3 teams. So there's us, the senior project mechanical engineering. There's electrical engineer doing it for a senior project, and we also had a capstone CPE team. Altogether, there were 10 students and 3 faculty members that drove this project.
To give you a bit of background on what combat robotics is, it's basically a rising sport in the field of robotics where robots of varying sizes designed by pretty much anyone who's eligible to compete go and compete in these large arenas and essentially fight to destroy one another. We were approached by our sponsor, Kirk Branner, who would like his own personal combat robot to compete in these competitions.
For manufacturing, we primarily manufactured all of the parts in the 2 machine shops here on Cal Poly campus, the Arrow Hangar and the Mustang 60 machine shop. Most of the operations were done on a mill, and a lot of the parts were water jet.
So the final design you can see in the center of the poster is basically composed of a mechanism drivetrain, as well as a hollow drum spinning weapon. You can see this subsystem breakdown in the bottom center of the poster, and those subsystems are the armor, the drivetrain, and the chassis and the weapon. The drivetrain design that we chose is Mechnum, and that's because we wanted our robot to be super maneuverable in order to outmaneuver the competition, which will hopefully give us a massive advantage in the arena.
For testing, we measured the backlash of each of the wheels, and because we're not currently using encoders on the motors, as the robot drives around, it will rotate in place, basically. So we measured that rotational drift either with the field-oriented control and without. We also did a lot of testing with the code that was given to us from the CPU team.
In the future, there will be other teams taking this on from us. Hopefully this project will continue year after year. Next year, there is a mechanical engineering team that will be continuing this project, continuing to improve upon our design, specifically in lightening the robot because it is currently overweight. This robot was designed for the 120-pound weight class, and in order to compete in that weight class, it has to be under that weight limit. So they'll be doing some structural optimization to figure out where they can remove material and get it underweight. And in addition to this, they'll also probably be working on improving the grip of the mechanism wheels so that we can have more traction on the ground. And then, of course, there's always lots of improvements that can be made to the electronics and software, specifically in the controls, and hopefully eventually implementing the encoders.
In the videos here, you can see the robot driving as it was assembled before the Senior Project Expo. And here you can see the demonstration of the robot during the expo.
We would like to thank our project sponsor, Kirk Branner, for presenting us with the unique design challenge and idea. We'd like to thank our faculty coach, Altari Elkand, for being supportive throughout the year in this project and for sort of helping us secure funding. We'd also like to thank the EE and CBE teams that designed the electronics and wrote the code that really made this robot work, as well as the Cal Poly shop techs for water jetting all of the major components on the Battlebot, as well as additional sponsors, NASA and Cal Poly Hyperloop Club gave us generous donations to allow this robot to exist.
Thank you.